we will be using the following piecewise function to answer the following questions. In order to estimate the limit as x approaches 3, we use values close to each side of x equals 3 in order to estimate what the output is approaching. As you can see, it appears the limit is 4. In order to draw the lower and upper boundaries, we use epsilon. We add and subtract epsilon from the limit in order to get the upper and lower boundaries. This is drawn on the graph, and the region the boundaries cover is colored in orange. Using the graph, we can estimate what inputs will give us a value within the error band. We can do this by going to x equals 3 and horizontally following the function line until you reach the point behind and in front of x equals 3 where the x value is no longer provides an output inside the error band. Using the previous graph, we can estimate that the interval for which x will give an output within the error band is between 2.65 and 3.35. And using that interval, we are able to obtain an estimation for delta by taking the difference between the lower and upper boundaries of x. In order to obtain a more accurate interval, we can use the graph trace function. Using this function, we got 2.71 is less than x is less than 3.26 for the interval. This means that the delta is equal to 0.26. In order to obtain delta algebraically, we must solve for x by inputting the upper and lower boundaries as f of x into their respective parts of the piecewise function. In conclusion, we have found that, in this case, the limit of f of x as x approaches 3 is equal to 4.